Hey, husband. I reopened this homework tonight, so if you wanted to go back and look at these last couple that I'm gonna go through a little bit, you're welcome to. So it looks like the first half of 9 went great, and then you got to the part where there's that x plus 1. So the same as you did up here, where you had g of 0, and that means we're evaluating this function at 0, or plugging in zeros wherever there's x's. It's the same thing down here, it's just we're plugging in x plus 1's. So like whatever's in these parentheses, I joke, if it's g of smiley face, you'd have 2 smiley face squared plus 3 times smiley face minus 7. Whatever's in there, that's what's going in for x. So let me kind of show you what that would look like over here. So instead of 2x squared, we have 2x plus 1 squared. And then 3, and instead of x, that's now an x plus 1. The same way if we're finding, g of 5, we'd have a 5 squared and a 5 right here. And then minus 7. From that, we just have to clean this up. I'm going to do a little scratch work up here for this piece because this is the trouble spot for a lot of folks. X plus 1 squared, a lot of times people get x squared plus 1 and they want to kind of distribute that. Remember that x plus 1 squared is really a FOIL. So it means I have x plus 1 times x plus 1. And if we FOIL all this stuff out, we'll get x squared. On the outside, I'll get a plus x. On the inside, I'll get a plus x. So that's going to make plus 2x's. And then on the end, I'm going to get a plus 1. And then I'll rewrite that over here. So this will be 2 times that result right there. And then plus, I'll go ahead and do the distribute here, 3 times x and 3 times 1 be, plus 3. And then minus 7 there on the end. And then let's distribute that 2 through there. So we got a 2x squared. 2 times 2 give us a 4x. And 2 times 1 will give us a 2 plus 3x plus 3 and minus 7. Like terms, and then we're pretty much there. So I got that's my only squared term, so 2x squared. For x's, I have a 4x there and a 3x there, so that's going to give us 7x's all together. And then for the constants, I got plus 2 plus 3 and minus 7. So 2 and 3 would be 5, and then minus 7 for minus 2. So this result would be what you get if you evaluate that function at x plus 1. The part 2 on this is actually quite a lot easier. So g of negative x, same idea, right? Again, whatever's in these parentheses, that's what's going in for those x's. So that will be a negative x right there. And then plus 3 times a negative x. And if you kind of think of there being parentheses around that, it's another way to write multiplication, but it maybe makes that substitution a little bit easier to see. And then minus 7 right here. So then, again, we just got to clean it up. So this little bit, this really means 2 times negative x times negative x. So then 2 negatives will make a positive, and then x times x would make x squared with a 2 in front. So 2x squared. And then negative and positive, so that'll be a minus 3x and a minus 7. And that would be it on that one. For this last one, number 10, if you go ahead and take a look at that, let me go ahead and clear this. Clear. That first part is just like what we just did. It's a little bit easier. It's a little less going on for that function than the last example. For this part, let me just kind of show you what that means. F of x plus f of 2. So f of x is exactly this, right? F of x equals 8 plus x squared. So that's all that part is. Plus, we're supposed to add f of 2 to that. And I'm going to put this in a parenthesis just because if this was f of x minus f of 2, that you would absolutely need those parentheses. So they're not strictly necessary here, but they would be if the problem was structured slightly different, which is to say minus. Here, this would be 2, we're plugging in a 2 and then squared. and then from there you would just clean it up. But so f of x just means take the original function and then add to it the result of plugging a 2 into that original function. And then, like I said, always simplify. Hopefully that helps clear that up a little.